We are now going to look at equations with fractions, but where the denominator is a variable. That means the letter of the alphabet. I'm doing the example on page 116, and still its equations, it is solved for x. So if I have this example here, we see that x is in the denominator. And still I need to find the LCD to get rid of my fraction. And the LCD in this case is x. So we are going to say, well, 1 times x is x, so x times 3 is 3x. 10 times 1 is x. What I do at the bottom, I also do at the top. So 1 times 10 is 10. X times 1 is x. So what I do at the bottom, I also do at the top. And 1 times 2 is 2. And it's x plus 5. Now we are going to remove the brackets. And we say 2 times x is 2x. And 2 times 5 is 10. From there, we are going to take all the x's to the left-hand side. And I get rid of plus 2x by saying minus 2x. The inverse of plus 10 is minus 10. We group our like terms. 3x minus 2x is x, and 10 minus 10 is 0. Now I look at my denominator. We say the answer of x is 0, but x is in the denominator, and if I divide by 0, my answer is undefined. So we say x can't be 0, because if x is 0, then my fraction is undefined. So in this case, there's not going to be a solution. I also want to look at D of exercise 5. I've got in the denominator x and 2x and 4. The LCD of 2 and 4 is 4, and then there is a x. So I'm going to multiply right through with 4x. So x goes into 4x 4 times. If I multiply the denominator by 4, I must multiply the numerator also by 4, and 6 times 4 is 24. 2x times 2 is 4x, so 3 times 2 is 6. 4 times x is 4x, so 1 times x is x. So we have 24 is 6 minus x. The inverse of minus x is plus x. The 24 must move to the right hand side, and the inverse of plus 24 is minus 24. And so x is equal to negative 18. And then you are going to substitute negative 18 in there, and you are going to say, well, it will not give me 0 in the denominator, so this can be true. We are also going to 5e, exercise 5e. I've got 3 and 3, so an x in the denominator, so my LCD is 3x. And I have to say 3x times 1 is 3x, so 1 times 2 is 2. X times 3 is 3x, so what I do at the bottom, I do at the top, so 1 times 3 is 3. 3x times 1 is 3x, so 5 times 1 is 5. 1 times 3x is 3x, so what I do at the bottom, I also do at the top. So now I must isolate my x, and this is 2 plus 3 minus 5. This gives me 3x is equal to 0. So x is equal to 0. And if I go back to my original question and I substitute x with 0, so 3 times 0 is 0. And the denominator can't be 0. So this can't be true. It can't be equal to 0, because then it is undefined. So in this case, again, there is no solution. You are now going to go to exercise 5, and you are going to try A, B, and F. And also on page 125, revision exercise A, 7, 8, and 9.